To create an associative forecasting model, we want to look at how another variable besides time would impact the variable we're trying to predict. So in this case, for our lemonade stand, we're trying to do some forecasting for how much lemonade we're going to sell. And we think that the sale of our lemonade is related to the temperature outside. And so what we have here is we have the sales from periods 1 to 15, so that's 15 days of sales, and we have the corresponding temperatures for those days. And so now what we want to do is we want to create a model that predicts the amount of sales based on our temperature in Celsius. So to do this, what we would do is we would highlight our sales and temperatures. Okay. Now notice for periods 16 and 17, those days haven't happened yet, and ultimately what we'd like to do is we would like to forecast what the sales will be if the temperature on the 16th day is 9 degrees, so a very cold day in the summer, and what if on the 17th day it's a very warm day and it's 28 degrees Celsius. So we're going to leave those off for now, but let's highlight the sales and the temperatures, and we're going to insert a scatter plot. Now if we take the data as it's given, so sales is listed first, and then temperature, notice that on our graph on the horizontal axes, it's going from essentially 5 to 30. That is our sales information. And on the vertical axes, you can see it is going from essentially 10 degrees up to 25 degrees, and that's our temperature. But the problem is that we don't want to predict the temperature, we want to predict sales. So in fact, we want sales to be on the vertical axes, and we want temperature to be on the horizontal. So what we need to do is let's right click, let's go to select data, and here you can see it lists the series as temperature and it has the horizontal as the 5, 10, 17, that's our sales. So let's remove all this and let's add our series. This way we can specify what's on the horizontal and what's on the vertical. So when you are graphing, except for in economics when you're doing a price and quantities for demand and supply, the rest of the time, then what you have on the horizontal or the x-axis is what you are going to use to predict something else, and what you put on the y-axis is what you are trying to predict. So we are trying to predict sales using temperature, and so we need on our x-axis to be temperature and on our y to be sales. Now you got to be careful when you are clicking on your data. If you double click, you'll end up with this 1+ and then it complains. I do it all the time, so let's just make that go away by deleting the 1+ part. So for our y value, we have our sales. And our series name, you can give it a name or select this information. This is our sales for our lemonade. So let's just click that. We'll hit OK. We'll hit OK here. And now we can see our sales. And on the horizontal axis, we have our temperatures. And in fact, you can go and you can add in some titles for the axes. And so we can actually label those titles if we want. And so we can make that horizontal axis say temperature. And we can make the vertical one say sales. Don't have to do this, but it can help you keep track of what's on what. What we want to do now is we want to fit a line of best fit. So we want to use temperature to predict sales. So again, we want to click on our plus sign here, and we want to add a linear trend. If you go to more options, you can then have it display the equation, because we're going to need that formula for forecasting. And we can also click on the r² value. This is the coefficient of determination. It tells us how well our model fits. In this case, an r² of 0.65 says that the temperatures explain about 65% of the variation in our sales. Okay. You can also choose to have the trend line go further than your data and go both the left and to the right on the ends of that trend line if you want to forecast forward or backwards. So we can extend that trend line a little bit if we want. So you can see I've put it forward 2 periods and back 2 periods, and so we can see a little bit of that line beyond the current temperatures. All right, so let's close that. I'm going to make this information here a little bit bigger so that we can see it. Let's try that again. Okay, make that size bigger. All right, so we're going to use this formula then to predict how much sales we have when the temperature is 9 degrees and when the temperature is 28 degrees. So we're going to put in a new column so we know that this is not actual sales but forecasted sales. Okay, and so here we're going to type in our formula. We take it directly from the graph. So we're going to put 1.0657 times, and then what we put in for the x is the temperature. And so if you click on cell C17 where that 9 is, and then we type plus 0.0757, then the forecasted sales for when the temperature is 9 degrees is that we will sell about 10 cups of lemonade. And we can drag this down, and when the temperature is 28, we're forecasting our sales to be close to 30 cups of lemonade.